Hello, my name is Mario Duenas, and this is my Lab 4 report. The purpose of this lab was to assess the motion of a mass while moving in an arc and oscillating on a spring, in order to use that recording and try to find and replicate it through GlowScript. The applications used in this lab were Tracker, Excel, and GlowScript. After collecting data from the video at each time frame, we were able to successfully replicate the oscillations seen in both the X and Y direction in respect to time. And we were also able to find our initial values for the GlowScript and able to replicate our findings. From the pre-video and the tracker data we found that the mass on the spring or on the oscillation was 0.402 kilograms. The initial position was negative 0.116, negative 0.64, and 0 meters. And then the initial velocity was 000 in all respects. The spring constant was 6.83, and the initial length of the spring was 0.123 meters. The equations we used in this lab were the position update formula, the velocity update formula, and the equations for spring potential energy, gravitational potential energy, and kinetic energy. In Tracker, we used a preset video in order to save ourselves some time, and we used the tracking mechanism in order to track the pendulum at each time frame. As you can see here, there's a circle pattern because of the oscillations in the mass. Additionally, we exported this data into Excel in order to get a CSV file and import it into GlowScript. Based on the data, we were able to replicate it through GlowScript later on if we got our code correctly. In GlowScript, after tracking, we inputted our initial conditions and also our spring constant in order to get the simulation up and running. Later on, we would update the length of the spring based on the ball position minus the spring position, and then we would get L hat and S from that. S is the difference or the displacement based on the spring. Later on, we would put in the energy formulas for K, UG, and US, and then we would add those together to get total energy. We would also calculate force of gravity as a vector. We would use 0, negative ball dot m, which is the mass of the ball, times g, and then 0 again for z. And then we would get the force of spring by the spring constant times the displacement times negative L hat. And then the F net force is just those two added together. After this, we would simply update the velocity and position after the loop, and then we would recalculate the energy in order to get changes in energy. And then after all that, we should simply get a oscillation in our results. So we would input our data, and then it would plot as red, and then in our model would plot as blue. And as you can see here in our results, they align very correctly. And then the delta E, or the change in energy, is also constant at 0 because it's not changing in the system. And then the other three are oscillating on the graph because they do end up changing in the system. Some errors that could have occurred in this experiment would have most likely occurred during tracking. For improper tracking, what I meant for individual frames would be differences in the ball placement, like if I went it through the center of the mass or through the edge of the mass. So differences like that would make some slight differences in the model and experimental oscillations. Additionally, the video that we referenced our mass from seemed to be different from the preset video we had, so that could have also caused error, and also improper calibration. In our model system, the energy principle is satisfied because it is a closed system. This means there's no external force acting or doing work on the system, which would therefore mean that the total change in energy is also 0, such as work. This is shown in our model through the orange line on our graph, which is completely flat at 0. For the period question on oscillations, we know that it is the time it takes to go from troph to troph on an oscillation. For the X position, I would say, based on the tracker data, that the period of oscillation is around 1.65 seconds. And for the Y position, I would say about 1.55 seconds. And then these two estimates are not going to be exactly identical because they each depend on something different. The y position one depends on the spring force, while the x position one depends on the pendulum or the swinging motion.